For chapter 1.3, we're going to be talking about matter and its properties. So matter is anything that has mass and takes up space. So this goes all the way down to atoms, all the way up to planets, galaxies, things like that. Okay? So mass is a measure of the amount of matter. Okay? Hence why matter has to have mass. Right? So energy is not matter, if you're wondering about that specific definition there. Okay. Another definition is volume. I'm sure you've seen this in your math classes, but volume is the amount of three-dimensional space that an object occupies. So matter is basically made up of anything that has mass and volume. So then when we talk about atoms, atoms are the smallest unit of an element that maintains the chemical identity of that element. Okay, so if you have a single element of iron, it's always going to act like iron. Okay, and it's the smallest thing that will act like iron. All right. Element, basically a pure substance that cannot be broken down into simpler, stable substances and is made up of one type of atom. So there are 118 different elements. You can find them all on the periodic table, right? Now, elements are defined based on the number of protons in their nucleus. Okay. Now, with elements, you can combine atoms of different elements to form compounds. So a compound is a substance that can be broken down into simple, stable substances. So each compound is made from the atoms of two or more elements, and they are chemically bonded together. That's what makes a compound. Okay, so when we talk about compounds versus elements versus atoms, that's the difference. Okay, so atoms, basically, it's a combination of protons, neutrons, and electrons. Element is a certain number of protons in the nucleus of that atom. And then a compound is a combination of multiple elements. And then you also have a mixture. So a mixture is a blend of two or more kinds of matter, each of which retains its own identity and properties. So if you take two different compounds, mix them together, but do not chemically bond them together, you have a mixture. All right, so this is asking, is it an element, a compound, or a mixture? So if we look at this, the red atoms, okay, so we have two red atoms bonded together here, and we have two blue atoms bonded together here. So the red is indicating that it's maybe element 1, okay? The blue is indicating that maybe it's element 2. So in this case, we have two different compounds, both utilizing their own individual element, but they're mixed together, so this is a mixture. Next up, okay, so it's not an element because they are chemically bonded together, which is why they look kind of smushed together, okay, but it's also not a mixture because there's only one type of compound in this. So this one is a compound. And then this one, actually, okay, sorry, this one is both a compound and an element. It's a little bit strange, okay, because it's elemental, so there's only one element involved, but it's not single atoms of that element, so it's also a compound. Okay, I know that's kind of weird, but if you had just an element, it would be like red circles or red spheres on their own. Okay, now this one, you have one red atom, so one element of element 1, or one atom of element 1, and then one blue, so one atom of element 2. Okay, so this one, because they are chemically bonded, this one is a compound, and just a compound. Alright, so element versus compound. This goes more into that you can have multiple atoms of the same element and still have it be considered elemental because it is just pure that element. All right, so this is looking at carbon atoms. This is actually a structure for diamond here. Okay, Carbon, pure carbon can actually form several different types of structures. So I think we'll actually be looking into that more later. And then here we have a compound which has carbon atoms in green, shown in green, oxygen in red, and then the hydrogens in this pale blue color. So this is a compound because it has more than one type of element in it. Okay? Alright, so now we have the characteristic properties. So we have what are called extensive properties and intensive properties. So extensive means that it really depends on how much of that matter is present. Okay? So this is volume, right? Because if you have one atom of an element versus, 6 billion, okay, you're going to have a greater volume with the more atoms or the more amount of that matter present than you will if it's just one little atom. Mass. Okay, so this goes into the same kind of thing. You increase the amount of matter, you're going to increase the mass. And then the amount of energy in a substance. So if you think about energy as kind of a finite package sort of thing that each atom holds on to, okay, the more atoms you have, the more little packages of energy you have. Right? So more energy present with more matter present. Then you also have intensive properties. So these don't depend on the amount of matter that is present. So you've got melting point, okay, because no matter how much of a substance you have, its melting point will always be the same. You also, of course, have boiling point, right? So if you have a giant pot of water and then a small pot of water, okay, both of them are going to boil at 100 degrees Celsius, right? Both of them will freeze at 0 degrees Celsius. Or if you want to do Fahrenheit, 212 degrees Fahrenheit for boiling, and then 32 degrees for freezing. Right? We also have density. So density is kind of weird. It's mass divided by volume. Okay? So mass and volume are both extensive properties, but density is an intensive property. Okay? So you can actually identify a substance based on its intensive properties. Melting point, boiling point, density, okay? And its ability to conduct electricity. So, I know it's a little bit weird, kind of a strange concept to get your head around, but intensive versus extensive. Also, the ability to transfer energy as heat. So if something can conduct heat, it's going to be able to do that whether or not you have a lot of the substance there or even just a little bit. So this is kind of going into some more detail about the different intensive properties. Okay, so remember, if you have basically a combination of different results for these properties, you can actually identify your substance. Okay? So, alright. Moving into physical properties. So physical properties are characteristics that can be observed or measured without changing the identity of the substance. So you're not breaking any chemical bonds. You're just kind of looking surface level at what you've got to try to identify it. Okay, so those are physical properties. Physical properties are color, its texture, different things like that. Melting point, boiling point, and then you also have what are called physical changes. So these are changes in a substance that don't involve a change in the identity of the substance. So you're not breaking chemical bonds, you're not forming chemical bonds, you're not creating a new chemical. So with physical changes, you can grind something, like if you're polishing a stone, you can cut it, okay? You can melt it, and you can boil it. Those are not going to break any chemical bonds, so it doesn't change the identity of the substance you're working with. Then you also have change of state. So when we talk about state, the state of matter, that's solid, liquid, gas, Then you also have plasma, and in some cases, supercritical fluid. And again, we're going to go through that later. Okay, so changes of state, or the state of matter, is a physical property. Right? So you can go through physical changes of a substance from one state to another, and that is still considered a physical change. So you've got liquid to solid, solid to gas, gas to liquid, so on and so forth. So this is a video that you will have online of a supercritical fluid, in this case called superfluid helium. Basically, it's helium under a very certain set of conditions, and so it acts as both a gas and a fluid. Okay, so it's a very strange substance at that point. We have been able to create supercritical fluids of various different elements, different compounds. They actually use supercritical fluids to extract caffeine from coffee beans to make decaf coffee. And then oftentimes we'll actually use that caffeine in different ways so that it's not wasted. Because that would be awful if you waste caffeine. Ugh. But superfluids are kind of strange. You can't get everything to go into a supercritical fluid. And then you also have to be very careful about how you use it, how you contain it, basically. So in the solid state, matter has a definite volume, okay, and it also has a definite shape. So this should be pretty obvious to you. If you have a solid, it's more difficult to change the volume and the shape than it is with anything else. In the liquid state, matter is going to have a definite volume, okay, but it won't have a definite shape. It will fill whatever shape it's put in. So whatever container you put the liquid in, it's going to actually go out and fill that shape. And then when you talk about gases, okay, this is where you lose that definite volume. Okay, so gases can expand and contract really easily. You can't really push a block of metal in, okay, work with me here. Let's say a block of wood. Okay, if you just take it and put it between your hands and try to push it, okay, it's going to be very difficult to change that volume or change the shape even. Now with liquids, again, if you were able to hold liquid in your hand, you can't smush it together. Okay, it's just going to flow out of the way. And then with gases, however, you really can compress them quite a bit. Okay, this is what we see with, you can also expand them quite a bit. This is what we see with internal combustion engines, okay, and a lot of various different things that we use. Okay, gas is compressible and expandable. It's also going to have an indefinite shape because just like liquids, it will fill whatever container it's in. In most cases, like where you are right now, the gas is filling the room that you're in. Okay, now that's a good thing. We're not talking about poisonous gas here. We're talking about like oxygen and things like that. Okay. And then you also have plasma. So plasma is what you find in lightning. It's what you find in the sun. It's a very high temperature physical state of matter in which atoms actually lose most of their electrons. So the matter itself is very free, basically. The electrons are moving throughout the plasma. Okay, and then you have just the rest of the atom kind of left behind. And then supercritical fluid, you actually have a very set of circumstances in which you can get certain compounds into a supercritical fluid. When we look at phase diagrams, we're going to look more at this. But again, it's the substance is acting like both a gas and liquid. So it's a very strange kind of thing. But we're almost out of time for this video, so this is where I'm going to stop with part 1, and then we will pick up in part 2.